All right, picking up with lesson 8-4. This is a lesson that should take you 2 days to complete. I'm going to post the whole video and let you decide where you want to split it, or, just get it all done in one day. It's up to you. But this is compound interest. So compound interest is interest compounded on the original principal as well as any accumulated interest. So these are typically seen in savings accounts and a few other places, but the most common one would be a savings account. So your formula for compound interest is A equals P parentheses 1 plus R to the T. This looks a lot like the formula you just did in 8.3, only now our T is an exponent instead of being involved. So that's the difference between simple and compound. Which, to read this, is future value equals our principal or present value times 1 plus our rate to the time. This formula is for interest rates that are compounded once a year. So down here we get into more than that, but once a year you're always going to use this formula right here. So number one, you deposit $1,000 in a savings account at a bank that has a rate of 4%. Find the amount A of money in the account after 5 years subject to the interest compounded once a year round to the nearest cent. So our principal amount was $1,000 given to you here. Our rate was 4% given to you here, but we have to convert it to 0.04. And our T is 5 years given to you here. Plug all of that in. 1,000 times 1 plus 0.04 to the fifth. If you have a cell phone, if you're doing all of this math on a cell phone, you're going to want to do this operation first, hit enter, and then do your caret to the fifth, hit enter, and then multiply it by 1,000 and then hit enter. So cell phones are a lot harder to do this math with than if you have a calculator at home, obviously, but I'm hoping some of you have calculators at home. But anywho, you get a future value of $1,216.65. B, however, wants the interest. So how much money did you earn by letting that money sit for 5 years, compounded once a year? So you take your future value and you subtract your principal. So your answer minus what you started with. So $1,216.65 minus $1,000 gives you accumulated interest of $216.65, which is not a ton. But for the fact that it's compounded once a year and you're just letting it sit, that's a nice chunk of change to let money sit in an account. So you've got compounding periods, which is the period of time between two interest payments. You're going to see compounded annually once a year. That's what we did up here. Oh, hey, help if everything was straight, huh? Semi-annually is twice a year. Quarterly is 4 times a year. Monthly is 12 times a year. And if you see weekly, that's 52 times a year. So that goes with this formula, compound interest in times a year. That is A equals P parentheses 1 plus R over N to the N times T, where N stands for the number of times it's compounded. So coming back up here, semi-annually is N is 2, quarterly N is 4, monthly N is 12. Logan, will you go restart the dryer, please? Thank you. So number 2. You deposit $4,200 into a savings account that has a rate of 4%. The interest is compounded quarterly. How much money will you have after 10 years, round to the nearest cent? So that $4,200, that's our principal. Our rate is 4%, and again, we've got to change that to a decimal. It is compounded quarterly. Quarterly, we come up here, quarterly is 4. So N equals 4. And how much money we have after 10 years? That's your T. T is 10. So plug in what you know. Future value equals $4,200 times 1 plus 0.04 divided by 4 to the 4 times 10. This is what you get. Again, if you're doing this on your cell phone instead of on a calculator, you're going to start on the inside. Do 0.04 divided by 4. Hit enter. Plus 1, hit enter. Caret, you really should not need to type 4 times 10 in the calculator. So you're going to take that number to the 40th power, hit enter, multiply that by that, hit enter. So again, cell phones take a lot of process, but anywho, after 10 years, you've got $6,253.23. So B wants you to find the interest. Remember, interest is future value minus the principal. So $6,253.23 minus that $4,200 that we started with. And it has gained $2,053.23 after 10 years, which, which would you rather have, that amount or that amount in interest? Obviously, you would rather gain that amount if we're talking about a savings account. Then you've got continuous compounding. That is when your compounding periods increase indefinitely or infinitely, not indefinitely. But that's just meaning it is continuously compounding. So this is A equals P E R to the RT. This E, that is found on your calculator. It's second and then your natural log button or the LN. It's e to the x. On your cell phones, I think you've got to turn it to the side or bring up the extra menu, and I can't remember where exactly it is, but I know it's on there. It's just going to look like e to the x. So principal times e to the r times t. So number 3, there we go. A sum of $10,000, well, that's our principal, is invested at an annual rate of 8%, that's our rate. Find the balance in the account after 5 years, that's our T. Subject to, we're going to do quarterly compounding versus continuous compounding. So quarterly compounding, our N is 4, and then we've just labeled everything else. P is 10,000, our rate is 0.08, our T is 5. Plug it in. You get your answer. You've got a future value of $14,859.47. B is running the exact same problem, only it's continuous compounding. So this is the A equals PERT formula. Same numbers in the same spot. That's our P, that's our R, that's our T. The only difference is the E. Plug it all in. You get $14,918.25. If you want me to do some fiddling around and try to figure out where the E is on the cell phone calculator, let me know and I'll get on that. But if you can see, continuous compounding gains you just a little bit more than quarterly. It's not a whole lot, but it is there. Number 4, it would help if I was on the problem. Number 4, find the accumulated value of an investment, that's supposed to be an investment, not an invest, of $10,000 for 5 years at an interest rate of 5.5% if the money is compounded semi-annually, quarterly, monthly, and continuously. So this is comparing all of them. So you are going to be reusing the same numbers over and over again. 10,000 is our P, 5 years is our T, our rate is 5.5%. So 10,000, 0.055, T equals 5. Semi-annually, our N is 2. Quarterly, our N is 4. Monthly, our N is 12. And you just keep plugging that in over and over again. So semi-annually, once we run our formula, we get $13,116.51. Running the same formula with a 4 in there instead of a 2 gives us $13,140.67. Running that same formula with a 12 in there instead of a 2 or a 4 gives us $13,157.04. And compounding continuously gives us $13,165.31. So as you can see, we are not increasing by a whole lot every time. Semi-annually to quarterly is probably the largest jump. But past that, it's just increasing by less than $20. So it's worth it, but at the same point, it's $20. So calculating present value. So this is working backwards. So we had 2 problems on the last one that were working backwards where you had to quite literally work backwards. 5, we could work it backwards, or you could use the calculating present value formula. So this is if I want this amount in X years, how much should I put in? So how much money, the formula. P equals A divided by 1 plus R over N to the N times T, which looks good golly, Miss Molly, which looks very similar to the formula we've been running today, just finagled around a little bit. So how much money should be deposited today? That's what we want to know. That is our P. P, there we go. In an account that earns 7% compounded weekly so that it will accumulate $10,000 in 8 years. So our future values, we want $10,000. A. Our rate is 7%, which is 0.07. It is compounding weekly. Weekly is that 52. And we're going to leave it alone for 8 years. Plug in everything you know. 10,000 divided by 1 plus 0.07 divided by 52 to the 52 times 8. And that gives you $5,714.25. So that's how much you have to deposit today to get $10,000 in 8 years if it's compounded weekly at a rate of 7%. You know, that's a lot to take in. So your effective annual yield, or it's also called your effective rate, is the simple interest rate that produces the same amount of money in an account at the end of 1 year as when the account is subject to compound interest at a same rate. Which simply means, you know, we're doing, where's my formula? We are doing this formula. We're doing a compound interest formula. What you did in your other notes, your notes from 8.3, was this formula. We are finding the number that's like, is a conversion rate. Like, we want simple interest instead of compound interest, so we're finding the number that is the simple interest. To find that, you do y equals 1 plus r over n to the n minus 1. And this is our annual yield. So. Number 6. You deposit $6,000 into an account that pays 10% interest compounded monthly. Find the future value after 1 year. So $6,000 is our principal. Our rate is 10%, which is 0.1. Compounded monthly, our n is 12, and our t is time, 1 year. Yeah, 1 year. Plug it all in. 6,000, parentheses, 1 plus 0.1 divided by 12 to the 12 times 1. That gives us a future value of $6,628.28. This formula right here, if I did simple interest rate formula, or calculating this future value of a simple interest, what rate would I have to have? So you're using the same numbers, you're using the same rate and the same amount of compounding. So 1 plus 0.1 divided by 12 to the 12 minus 1, that gives us 0.1047. That's not a percent, we need a percent. Multiply by 100, you get approximately 10.5%. If you wanted to put 10.47%, that would be fine. But that just means to get the same value using the notes that we did yesterday instead, you would have to have a 10.5% interest rate instead of a 10% interest rate. So this is comparing rates. Number 7, what is the effective annual yield of an account paying 8% compounded quarterly? Our rate is 8%, which is 0.08. Our compounding is quarterly, which means 4. So 1 plus 0.08 divided by 4 to the 4 minus 1, and that gives us 8.2%. So, all right, your homework is page 521. Your directions are on page 520 in the bottom left corner. I'll be uploading those pages later, but you're doing 14 through 24 even. Let me know if you have any questions.